Hello and welcome back to another session of serde-yaml. It's Byron speaking. And, well, it's gonna be a very interesting day, I think, just because we are in a state where lots of stuff is not working because we have to implement so many different things to get to allow us to actually fix the stuff that we have to fix. We added mapping tests, which all kind of fail. And also learned about YAML Rust, which will be a great source for, great source to see how stuff can be implemented in a working manner, and how usually these or the YAML parser is implemented. So I don't have to start from scratch, even though I would consider this. We are in a different environment here, so having custom code to deal with that is probably not the worst idea, as long as this custom code is as good as the current libyaml based implementation that I think YAML Rust kind of works with as well, or is based on libyaml and YAML C++, as it says itself. Okay, so let's run some tests here. Cargo test sir unit. That should do something. Oh. Okay, I have changed some overrides here, which hopefully doesn't break stuff for me, but I will see. That should just work. Yeah, hopefully it does. I think now I have overrides here that I didn't have before, even though I do not need them, right? So, come on, show me something. There we go. So, explicit entry mode, that is a test that is to do. But here, complex keys. Yeah, two things here. I thought about that yesterday. And right now, we have special handling for is mapping key. And I think this is something that we kind of get wrong right now. Because is mapping key is just set while the serialize call is dealing with a mapping key. But what we are actually interested in is to know if we have a complex key, right? This is mapping key is really not that important after all. And is complex key is the case if the key will open a new structure like a sequence or a mapping. And this is something we probably want to add here. The good thing is that we cannot mix scalar values and standard values. Therefore, in the moment we call open once, we know that we are in a complex key situation while we are building a mapping key. So maybe we rename this to say sir mapping key. Signals that all serialized values are going to, maybe this is what we want to put here, and this is true while we are serializing a mapping key, but we will not use this directly, not as directly as we do now. So I think in the open implementation, we want to see that, well, we want to check that if self sir mapping key, then we say, well, self is complex key true, because this is the indicator for that. And if we close that, we want to turn it off like this. And now I think wherever we use the sir mapping key variable for reading, we actually want to use, here for instance, we want to use is complex key. And now this kind of makes sense. The cool thing is that currently we had I think we ended up here in the complex key section, which we didn't want yet. And now this won't happen anymore. That's a great fix. So now we should end up in a situation where we have to implement some string serialization stuff that is related to folding. Well, is complex. Oh yeah, true. I'm not in, when creating a new instance, I'm not actually doing anything with it. Here we go. Is complex key shall be false initially. There we go. So now it should compile, and the panics we see, the test failures, should be related to something else now. Escape handling. See? So now we have to deal with a string. And the great news is that actually we can totally look at how this is done. Of course, in the spec, but also in the YAML Rust implementation. I've created a project for this already because I will look at it all the time. All the time. So where is that? It's the emitter. Emitter is doing all the work. I guess I want to just copy the file path, serde-yaml, and open this up here. Just to have it. Okay, so first let's clean up a bit. I have way too many files open here. In, I do not need serde, I do not need sergen, I do not need fixed. Could be interesting. And 3 files are manageable on this side. So emitter is here. And yeah, I don't know. Maybe I put it on that side anyway. Good. So now we end up at, if there is something to escape, we must use blah. Okay. So if there is, so here we panic right now. So what's happening? Where are we? We are in an encode scalar. And this stuff is already, oops, I didn't mean to do that. This stuff is already settled. So now we want to deal with flow mode. And flow mode is the one that supports plain or one of the quotation styles, whereas block mode is the literal style or folded style for scalars. This is mainly relevant to string values, but not only. Let's just verify this. So if we start a document here and we start it in literal mode, then we can say, well, it's 1, 2, 3. That shouldn't work, see? Because this counts as indentation. 1, 2, 3, and we can go as far as saying this is supposed to be an int. Okay, now it got it. And it's an int. So this is basically the flow mode, right? We could also say this folding mode, which is in this case the very same thing to us. But anyway, this is the block mode that we currently do not support. Right now we are only interested in basically stuff like this. Wait, if we have a string, right? So the simplification we have here is that if we are not a string, then we know that we have ASCII only characters, so we don't need to do escaping tests, and we don't need to do test for folding. Because right now we support configuration values for a maximum width well, let's just have a string here. It's totally valid to say something like foo bar. See this? And this line break here will automatically be, okay, so it strips apparently, and the line break will be a new line. The line break will be a space then. So this kind of folded mode within brackets, and every empty line results in a new line, as well as indented stuff, which I think, oh look, what's the indentation? I thought indented stuff seems to be no special here, huh? Because indented stuff is special in folding mode, but not here. Let's have a key value thing going on. Key 2, so now we go with folding mode. So that's the first line here. And then indentation should matter. Okay. See, now the white space is not truncated. Yeah. And then the new line also matters. See, that's kind of a literal mode. I see. Awesome. Yeah, just checking, because this is something, I mean, not that, but that. This is something we now have to implement kind of somehow, at least partially. And I would totally be fine, you know, to not deal with, you know, this stuff, folding. We just don't implement it for now. But the escape handling we have to implement. This is why we are here. And look at that. There is some nice escape handling here. This is, I think, the implementation of JSON somehow. And look, he took it from serialized JSON. And let's look at the spec for once, because there is a lot of information about escaping stuff here. So I think this is JSON. This is what we see implemented here, do we? To ensure JSON compatibility, must allow all non-controlled characters inside quoted scalars. To ensure readability, non-printable characters should be escaped on output, even inside such scalars. Note that JSON quoted scalars cannot span multiple lines and cannot or contain tabs. Oh, interesting. Sure. But YAML quoted scalars can. Yeah, so that would be a question, huh? Right now we have a JSON mode. Let's figure the configuration out first, because this one here seems to be based on JSON, but that's not exactly what's allowed or what's correct for YAML, right? That's how it looks like. So to ensure readability, YAML streams use only the printable subset of the Unicode character set. The allowed character range explicitly excludes the null character block from null to 1F. Can I see this here somewhere? That's, oh, null E, null B, yeah, null. So here, that's the null character block, apparently. Except for X9. Sorry, for 9, basically. So here we go. 9 is missing. And that's the same here, kind of. XA, XD. So it seems that XA is supported, huh? The question is, and the thing is, that's the visible ones, that's the allowed ones, right? Up to 7E, 7F. Yeah, I'm totally not sure to implement that correctly. Except for testing all the ranges explicitly, which obviously could be done. And maybe that's what you want to do. But the point is, on input, a YAML processor must accept all Unicode characters except those explicitly excluded above. All right. On output, a YAML processor must only produce acceptable characters. Any excluded characters must be presented using escape sequences. In addition, any allowed characters known to be non-printable should also be escaped. This is mandatory since the full implementation would require extensive character property tables. Okay, so that's not mandatory. To ensure JSON compatibility, JSON processors must allow non-control characters inside quoted scalars. They should be escaped and output even inside such scalars. Note that JSON quoted scalars cannot span multiple lines or contain tabs, but YAML quoted scalars can. So what happens on tab here? Let's try to investigate. Let's warm up a Python shell here, and I will try my best to somehow use it. So this is ord9, so it's x9, right? Tab is allowed in YAML, but it's not actually allowed in JSON. So let's get a tab here. That's a silly way to get a tab, but for some reason, everything I tried so far is actually converting tabs to spaces, and obviously I'm not willing to change any settings here. So having a plain file, tabs will just be tabs. And yeah, so it says tabs are fine in here, right? Okay, it's stripped at the end of the line. But here, the indent stuff, there it should not be stripped, right? Yeah, I don't see it. But it also doesn't seem to update particularly well. Oh, I'm looking at the wrong one. We are at key. I'm looking at K all the time. Well, but there is no tab. Even though a tab is here, I don't see it, and now I also don't see any update. But there, it seems to strip it. Tabs are allowed, but they are stripped. So I guess it's actually a good idea to say, well, if you want a tab, we can put it in like that. Yeah. So I think I would do the same thing, huh? I would encode it like that. On the other hand, we shouldn't solely rely on this. I would also see how a real YAML parser does it, and just see how it's implemented, convert that to Rust, I guess. This is what I would want to do. So that's the first thing. Let's see what we want here. Yeah, and this seems to be from serde. I've seen the same code here, also with the way it handles the start and, writes stuff on demand. I would do it differently though. I would want to write to a buffer that I keep and reuse. So let's start. Let's get some PyYAML going. So I should have YAML here, and I hope the implementation is somewhat readable. I have no idea, actually. Let's see what we have. Should be the emitter, huh? Maybe it's the dumper, I don't know. No, that's just... So it could be the emitter. Do you have something like encode? Let's look, there must be something. Analyze scalar. Interesting implementation, analyze scalar. Check for line breaks, special and Unicode characters. Wow. That seems to be the Lexer part, huh? Scalar analysis. Wow. But it goes through all the characters here. So the Lexer is kind of included in that implementation, it seems. Jesus Christ. Boah. State machine. I like to have an explicit Lexer for exactly that reason. Then you don't deal with that stuff. You have the problems nicely separated. Yeah, so far no... Oh, here, some escaping. Right single quoted, look. Escape replacements. So I guess it will prepend it with whatever is there. Yes, yes. As a lookup table, we have a match for this. And here's, I think, the interesting part. This is the part that deals with the ranges. Yeah. And if character is smaller than FFFF, let's look at this. There's probably plain text here somewhere. Yeah. This is this. Kind of. I'm not sure if this is per se correct now. But I guess it better should be. Well, it's interesting that he needs these Unicode mega strings to do anything. Ah, if it's in, that's a new line, and that's probably different Unicode encodings for new lines. Oh. That's annoying. Look, if a line break is that complicated in Unicode, then I'm certain that I don't do it. So Unicode code points 2028 line separator. Look at that. I didn't know. Gee. And the 29, what's 29? Can I just put this in here? Paragraph separator. Oh, so this also counts as new line. All right, see, I didn't even intend to support that. And the line break characters I propose, they're currently not including this x85. 85 is this, what's 85? Let's see. That are all Unicode code points. So 85 should be something next line. Whew. But look, it doesn't deal with carriage returns. So the Windows style of a new line and carriage return, or carriage return and new line, is probably not supported here. Whoa. Parsing this is going to be fun. I'm not even getting into this because it's also interesting. To see that as part of the emitter, right? I would more or less think this is more on the side of the deserializer, but maybe not. Apparently not. Okay, so is this handled somewhere? Yes. So this is what? So that's basically a new line, right? So what's FEFF, which code point? Hopefully it can convert that. Nope. I think like this, huh? With base 8. I don't know how that works actually. I thought this works automatically, that it can do these hexadecimal decodings. Or is it O? No. Maybe it wants it. Oh yeah, sure, I'm dumb. I can actually just put it in here, huh? Like that. So 65,000, is that a Unicode code point? And if so, which one? It's not a valid Unicode character. Interesting. So here we have new lines, and whatever that is. FEFF, is this part of the byte order mark? Damn it, now we get into an area where I have no idea. Is this mentioned here somewhere? FEFF? Byte order mark, there it is. FEFF, yeah. FFFE. Depends on the endianness of the data as well. For more information, so what? The recommended encoding is UTF-8. If another encoding is used, it is recommending that an explicit byte order mark may be used even if the first stream character is ASCII. For more information about the byte order mark, see the Unicode encoding schemes. Oh yeah, fun. And I wonder, this is not the only byte order mark, is it? Ah, Jesus. Lots of stuff I don't know. FEFF. Byte order mark consists of the character FEFF at the beginning of the data stream, where it can be used as a signature defining the byte order and encoding form primarily of unmarked plain text. Under some higher level protocols, use of BOM may be mandatory or prohibited in the Unicode data stream defined in that protocol. All right. Ah, look at that. Here we have FFFE. Because of the endianness of the value. The former is called big endian, the latter little endian. When data is exchanged, bytes that appear in the correct order on the sending system may appear to be out of order in the receiving system. In that situation, a BOM would look like FFFE, which is a non-character, allowing the receiving system to apply byte reversal before processing the data. UTF-8 is byte-oriented and therefore does not have the issue. Yeah, sure. Yeah, so I guess they only deal with part of it, right? So even that wouldn't be correct on a little endian system. Order, LE, endian, nothing. All right, let's get lib-YAML. I would like to have an implementation that is supposed to be correct. Like, correct, and all the nasty nitty-gritty details. That's something you want to at least know about, I think. And I guess that if you would just follow this information here, you would already be good. Let's get to escape characters right here. Oh, also nice. I mean, that's just valid escaping rules, right? And we will probably do the same. So we use letters whenever possible, and in all the other cases, the respective 8, 16, or 32-bit Unicode escaping. I think that's what you would want. So let's have a look here again. So here it does it. It spits out the respective letter, but doesn't know all of them. After all, we need for encoding. I mean, that's also something we came to look at. We want to know if we need some special flag to enforce JSON compatibility here. And JSON might not know all of these after all. So when encoding stuff, how can I take options here? Currently I have no encoding options, but these are only relevant for the single and double quotes style. So I could just put in some additional option there that doesn't make the configuration easier, by the way, that says what kind of encoding I want to have. So either a JSON, enforce JSON compatibility, yes or no. Encoding style, YAML or JSON. So in JSON mode, you probably want to have JSON encoding style. And because JSON is supposed to be a valid subset, this is what you can go with. And probably that's why this is okay to do, right? This is probably why this is done like it is done. Yeah, probably. But I wonder, you know, all these extra characters here. Capital N, what's capital N? Ah. Capital N, L, P. So what's capital L then? Is this even in here? R, E. Ah, big N. Oh, that's the 85 character. We've learned about that. That's the next line or something. Next line Unicode. Oh, here we have the additional ones. Line separator. That's the Unicode, guys. Now I get it. Awesome. And I think these are probably not supported by JSON, are they? Let's try it. JSON load S, right? Load S takes a string, and we might just give it foo equals. Let's try this. Can it do it? Oh, and I probably want to have a single quoted string here. No JSON object could be decoded because is it this one? Oh, look at that. So it can't do these. So the encoding style does matter after all. So this is JSON compatible. And what happens if we hit something like a Unicode, one of these special Unicode things? Then we also want to escape this one, right? Huh. And we wouldn't, this code doesn't even do that. This code doesn't handle this. What if I did, so N is 2029, right? Or P. Oh, where's N again? N and N. That's 85. Let's use 85. So this one it doesn't know, but does it know 85? Can't decode by X85. Okay, it's a Unicode code point. Invalid. Okay, so it needs 4 at least, and hexadecimal. Where is it? No, wait. So, okay, let's get 85 here. I'm sure I'm just specifying it incorrectly. That's HTML style. Hex. And what's the Unicode? UU0085. Okay. Did I not try that? I did. Okay, so here we go. This is JSON compatible, but it also needs this kind of encoding. And right now, it's just not here. It's not there. Nobody even uses this, but on the other hand, I think we have to deal with it. This code doesn't deal with it. Yeah, it's you know, that's the thing. It's really difficult to do that correctly. And if this is copied from serialized JSON, let me check something. JSON sir escape string. Oh, interesting. Interesting. Look, so who copies from whom? I think if this is serialized JSON, so Rust sees serialized JSON, right? Then this is Eric's version, which looks very, very similar, except there is not so much done here. This, I think, is relatively complete, but also doesn't seem to deal with certain codes that you want to deal with. Also, this is based on bytes. Huh. And we want to deal with, yeah, well, let's see what happens. Because yeah, so this is only in the lower ranges here. 85 is not part of the equation. Okay, we are already 36 minutes in, and all I did is some research. Well, and a little bit of improvements. It's a refactor, kind of, that I should call out here, I guess. So, long story short, would I want to use the Python implementation? Maybe I want to look at it. Oh yeah, let's get another reference before I terminate this session. So I think we are one step forward because we know that apparently we need some sort of encoding. Maybe I just want to put this in right away. But first, let's commit what we have. And that's a refactor. Refactor sir is add is complex key code path. It replaces, it amends and replaces the previous sole flag. Is mapping key. And allows us to finally get to the point where we can encode a string. The latter will require additional options to help us remain JSON compatible, or enforce YAML compatibility depending on options. That's kind of repeating myself, right? So skip CI, that is that. And now I would like to get lib-yaml, GitHub lib-yaml, is it there? I hope so. Yay, awesome. So let's clone that little bugger. Documents dev ext cd. Do I have lib-yaml already? lib-xml? No. Let's get it. And in the meanwhile, do I want to have? Yeah, let's see what it comes with. A makefile, bootstrap. I actually don't want to build it. No need. CMake. Oh, CMake list file. That's awesome. Because we should be able to do a make dir build, and then we can go we can call CMake on this one CMake build type is debug, and that should already be enough to configure this, see? And now I can use Qt Creator. Yeah, first I can probably build this, make something. See? Wow, that's it. lib-yaml is just that. It's amazing. and Python looks totally the same. Anyway, now I can open up Qt Creator and open a project here that is based on CMake project file, see? And let's just go there, dev, ext, lib. I always have to search. How's it called? Lib-YAML, right? Here we go. And now it's in build, and this guy at once. So we can use this. Oh, it doesn't know the CMake executable. Really? User local bin CMake, what's your problem? Yeah, now it has it, awesome. I think this is something I do not need. Should just work, huh? Exactly. Oh. Yeah, so now it has the sources and what's relevant to us. I think we could even go full screen on that one. And yeah, what am I looking at? The emitter, right? The Python implementation seems to be a pure copy of it. Gee. Except that it uses considerably less code. Yeah, so that's nothing we would be interested in. The emitter. Wow. 2,000 lines of code. And maybe I can make it a bit smaller here. Good, so here, look, that looks like, right, double quoted scalar. This looks like some encoding happens here. And yeah, how does that work? Unicode is ASCII. Oh, look. If not is printable, or emitter, or not Unicode, and not is ASCII, or is bomb, or is break, and it always works on the what is this? A YAML string type. Start pointer, end pointer. Okay, I don't want to understand this necessarily. I just want to know if this is truly a kind of string. But so is printable would mean it iterates the entire string, or what? Is printable at. At 0. All right, so it tries to detect that based on just the first one or an offset up to this. And it uses bytes to do that, which is the same thing, which is something we can also do in, which is something we can totally do in Rust as well. So that seems to check for byte order marks, huh? Or something? FFEF. So EF is here. And do we also check for FF? No. No idea. Probably some special routine. Here we have these ranges again. So interesting, I think this is something I would trust more. That's the point here, right? Where's our reference for this escaping stuff? So if it's not printable, if it's a bomb, if it's a break, or if it's one of these, this is basically our match expression that we want. So here we can match on the stuff and output the encoded value right away. Which is similar to what we have here. How does that work again? we get an escaped string. And where's start adjusted? Oh yeah, we continue here if it's nothing. And if we have something, then we write the string so far, write the escape string and adjust it. Yeah, that's how that works. That's pretty cool. Yeah, I like it. However, yeah, I think this is what you want to use as a reference, just to verify against it. And this is YAML, and it doesn't care about JSON compatibility, does it? Or maybe it does. So what does it do? ABT. So here it deals with the individual known cases. And this is also NTR. So for instance, this adds an E here and a V. So is that JSON? Yeah, so I think I can close this one, huh? So is this JSON compatible? Let's try it. Good. Invalid escape. So this kind of stuff is not even JSON compatible. So I think what we have to do, look at that, here's an N. We need 2 escaping routines. We have to check which one we want. And what happens if we get something like anything else that is unprintable? 85, that was here. Oh yeah, true. 20, it also has support for 2028, 2029. And what kind of value is that? Is that now an integer or something? Unsigned int, okay. So that's kind of their equivalent to a Unicode code point to a char in Rust. Makes sense. And yeah, this is the interesting part. So if the value, okay, here it sets the width and the prefix. And this is also something, yeah, I like this. I think this is something we can use here. Width, and then we deal with the width and put the respective, and convert the respective number into hex. Yeah. So that's hex style. And I wonder how we do this most efficiently in Rust. Probably there is some sort of function for this that does it, but we have to deal with with buffers and so on. But anyway, this is what we want. And the escaping in this case also deals with folding. Does it? Allow breaks, not spaces, YAML emitter, write indent. Yeah, so this guy does this function seems to be doing everything. It's at 2000, line 2000 something. Emitter, write, double quoted scalar, see? Emitter, write, single quoted scalar. So single quoted are not even supported. Oh, you know what? Only the double quoted scalar is supported anyway, so only this needs to have information about whether it should be JSON or YAML compatible. Awesome. So I think this is something I can already do here. This is something I can conclude to be true. We are not using our bandwidth efficiently because I'm running out of material to upload. Interesting. Anyway, that's kind of the first real session for today, and once that is done, I will be fine again. So that's problems I have. I'm maximizing my bandwidth usage. Anyway, so what I want is, where is it? Do I have sir here somewhere? I do. The double quoted style now needs to have information about string encoding. Where's the double quote? That's a flow scalar style. Here we go. Let's put it here. Pub enum double quote or string encoding format or something, YAML or JSON, identifies how we will encode unprintable characters within strings. Use YAML encoding rules. Let's refer to something, shall we? I think it's pretty much this one. Is this that? If I hit enter, do I get here? Yes. So that's about escape characters, and then it's about printable ones. Is this? Yeah, so that's just the character set that we have to deal with. Based on escaping rules specified here. Well, based on escaping rules, based on these escaping rules, let's just put it like this. Damn it, because I don't match the line here. On these escaping rules, and what else? Then we have not this one, but the other area where we deal with not that one. XFF. This one, character set. 5.1, give me a link to that character set. Based on these escaping rules and the YAML character set. That is that. So the JSON one is a bit different. And the question is, do I trust this code? Actually, I would be inclined to do so. I might also bring up JSON here just to see if this kind of matches, just for the trust. Open JSON encoder. I think encoder should have it. Look! Has UTF-8, escape ASCII, escape. Okay, that's the standard encoding format. I see. That's how it does it. That's how it sets the format. That's a lookup table. And look, but that's kind of the way. That's interesting. That's the way serde does it. Why do I have a new window open here? Ah, because I opened it with open. That's a bit better. So that's JSON now. And that looks very similar to this one. Even though it doesn't seem to deal with the range to 20 that it should deal with. And that's the only unprintable characters that we usually have to deal with. And this one does it. So that's the better solution. So this serde thingy is actually kind of wrong. Okay, so this is what we want to take for JSON encoding. And then we need a new one for YAML encoding. And yeah, let's finish this up in the sense that we started doing this stuff here. Where do I find the reference? JSON.org. And where is the printable? Okay, it doesn't even have that notion. String, char, what's the char? Any Unicode, here, that's a char for him. Any Unicode character except or control character. It doesn't tell anything about this printable range that totally matters. That totally matters here, and that also matters for this guy. Why any Unicode character except Maybe this is implicitly a control character. So if you just go by the book here, this totally doesn't work. Yeah. Okay. Anyway, let's link to JSON.org. Any JSON, yeah, use JSON encoding rules as somewhat indirectly specified on JSON.org. JSON.org. GitHub. Reference implementation is YAML Rust. Boom. I think I should link to that, even though I'm not a big fan of linking to this. Let's link to a commit here. Check the history. So here we have a commit. Now I can, where is this again? In emitter RS. So now I can view it here and dig down to the line here in that particular commit, so that will not change. That's very nice. Yeah, let's note down everything we use just for our own reference, because at some point we'll sit here and ask ourselves why the heck we did that. And yes, I want to shorten this guy. Voila. And here our reference implementation is lib-yaml, and here we do the same game, except for, do I have copy path? Do I have it here? Copy full path to clipboard. Yes. Let's open it up. GitHub. Yeah, I think it's at 2000-ish. Oh, 2000-ish here. GitHub copy link to file should work. Now I can do my drill down manually again. Am I ready to close this one? Not quite. One day I will. So let's go in here. And now we do, oh man. Do the history game. Let's use the latest one. Not that it would matter. There we have emitter. Let me search for 2020 or something. Oh, actually here it is. Voila. And that's our example line. Voila. Reference implementation is lib-yaml. Okay, so that should be it, right? That should show what we are doing. And I think it's really important to build trust. And building trust means you question everything and you find implementations that you trust in, so that you don't have to think about that stuff yourself. I mean, many people smarter than you, smarter than me, have done that already, and I want to learn from them. I want to be sure I don't repeat certain mistakes that probably still are in lots of code bases. I don't want to point at anything. right? But this probably is not the right way to escape stuff. And I guess I will totally start using my own serde-yaml encoding decoding facility with JSON style just to have it. So this guy now, 1 hour in, so time to finish this up. This guy now has a string encoding format. Escape format. String escape format. How we will escape unprinted characters within strings. That's exactly that. So that's an escape format, and now wherever we use double quotes, we have to do something about it. Escape format, so that is JSON, right? So escape format is JSON here, totally. Double quote, wherever we use double quote, we have to do that. And yeah, some code might stop working now because we don't use the flow scalar style correctly anymore. Double quote, yeah, we don't care about this. That is fine. Literal plain, yeah. And that's canonical. And here we use YAML now. That's the fun part. So by default we use YAML, obviously. But here we also use YAML. Double quote. By default, because that's a canonical YAML one and there's no need to be compatible to anything. Voila. Yeah, and I like this because many implementations might not have had the JSON stuff in mind, and Spec 1.2 explicitly kind of has JSON in mind. And I think it's about time to try to implement it that way, at least. Okay, with a little bit of luck, that will totally work. Right now we don't do anything else here, I think. Encode scalar, let's go there, and here we are. Flow style. Yeah, that's the flow style that we want to match on as well then. And this is something we might change in the process. So if we figure out that we have to escape this thing, you know, we do what we have to do. And the folding stuff might be a separate step here. So escaping will probably happen after folding, right? Because no, escaping should happen before folding. Yeah. The cool thing is now we can just put it in anyway. So that doesn't matter. Does it work? Do we still compile to the... Oh, that's the wrong one. Do we still compile? Escape format. Oh, okay, needs clone. Fair enough. Escape format. Here we go, go. Derive. Yeah, let's have debug, partial equality, the typical set of stuff we kind of have by default, and maybe in our library. Oh no, we don't do that. We just export sir. Okay, that's how that works. Good. So in theory, the test sir unit will not fail anywhere else. Oh, wait. Here we set the double quotes in sir unit. Sir, oh yeah, where do we do it? Here we do it, double quote. And we then want escape format. Well, it doesn't matter, but we have to set it anyway. Let's give it YAML, because that's kind of YAML style anyway. Let me put it here, and I think we have to... Oh man, line breaks. Have to explicitly import it. Escape format. Voila. That should compile now and fail as it failed previously. Awesome. So now escaping is what we have to do. And you notice encoding that I'm currently doing. Instead of writing UTF-8 encoded bytes, I kind of feel that I want to put this into a separate crate or something, because this can be generalized, I guess. I'm not sure about the bomb handling, but there probably is a way. But that's just a different thought. Right now I don't have to care about this because it's abstracted far enough to allow us to easily switch to another system here. But anyway, so what do we do? Add an escape format. Feed sir escape format. This enum is only useful for defining how double quoted strings come on. Actually, that's not the right one. Yeah, it's specified. I forgot to document it. The escape format, if I could spell it, indicates whether or not JSON should be supported, basically. Should be handled, i.e. JSON or YAML mode for escaping strings. And again, skip CI. That is that. I think this concludes this session once I have amended this commit, because next up is actually implementing this for the two cases. So thanks for watching and have a great day.